are model-based design, control design, model-based analysis. What is the meaning of that? The meaning is, first you find out the model, then you use that particular model to do the analysis and subsequent design. Clear? Model-based. There is a model-based design. Another is model-free design. Model-free. But most of the control designs as well as analysis are model-based. Okay? The classical controller, when you talk about classical controller, okay, they are based on the transfer function model of the system. When the term classical controller comes in picture, classical controller, that is based on the transfer function model of the system. Always remember, I am again emphasizing, which I will continuously emphasize in this course, that models do not exist. It is a mathematical abstraction, right? The phenomena exists. Don't miss that. If you miss it, then everything is lost. Your understanding is lost. Now, suppose we will see tomorrow how to model by transfer function. That we'll see. Suppose the transfer function model is given, then how to analyze the system, model-based analysis, classical analysis, and how to design a controller. Classical controller design is based on the transfer function model of the system. 1960s, a new model came up in MIT, state variable model. The state variable model that gave a name, different name, not classical control, it came the modern control. Modern control, when I say modern control, it has nothing to do with modern as we say today, right? Modern control is those control techniques which are based on the state space model of a system. Got my point? Modern control has nothing to do with the modernity. It is based on the state variable model. It is based on the state variable model of this system. What is state variable model? Let us understand these things, then before we proceed. This is the point. This slide, let's see. A system having n number of independent energy storing elements can be modeled. See the wordings I am using here, be careful. Can be modeled, I am not telling is model. Modeling is your choice. You may model it, you may not model it, right? A system having n number of independent energy storing elements can be modeled by a single nth order differential equation. So what the state variable model does, it does not use a single nth order differential equation, it splits it. The state variable model essentially represents the nth order system by n number of first order differential equations. What I point? The single nth order differential equation is now represented by n number of first order differential equations. Okay? So therefore, thus a single nth order differential equation here becomes n number of first order differential equations. Right? Now why it is that? Then it becomes easier to solve and do the analysis. Because all the equations are first order. Right? Just one example to give you, because suppose here m x double dot mx double dot plus fx dot plus kx is equal to u. So if I define one x1 is equal to x and x2 is equal to x dot, then the first equation will be x1 dot will be equal to x2, right? And x2 dot, I'm not entering into that because that is equal to x double dot. If you take it to other side, you will find this is the case. And this system is now represented by x dot is equal to ax plus bu and y is equal to cx. So instead of a single higher order differential equation, you can split it into only first order differential equations, right? I assume that you know state space model, right? And all the analysis and the controller design which is made by this state space model is called the modern control. X dot is equal to x plus bu and y is equal to cx plus du, right? One is dynamic equation, another is algebraic equation. Y is equal to cx plus du is the algebra. Anyhow, this is the point. I will take a little more time. I will tell you, if we will answer this question, our understanding about control engineering will be around 70% clear. Only simple this question. Is it necessary to use a controller, to design a controller? People say, we have to design a controller, right? Is it necessary? Is it a mathematical gymnastics that we will design a controller? Okay? When we are doing PhD in England, in the postgraduate office, there is a news some 2-3 pages writings every week comes. Why should you do PhD? Once it has come up. When I was doing PhD in 1994, one thing is, if you will do a PhD, people will think that you are intelligent, although you are a bloody idiot. You are an idiot, you have no brain, but you are doing PhD. You know what is the meaning of PhD? You know it. I am telling you, it is recorded, that's fine. The people listening to live streaming, they will know it. That these are the foreign faculties telling these things. One day, one fellow from Fiji National University was talking to me and he told me, who will do PhD? Those people who has passed high school with difficulties. PhD. Only those people will try to do PhD. And then, once they get enrolled into PhD, then this screw will become little bit loose. There will be partial head damage. PhD becomes, from past high school difficulties, it becomes partial head damage. And after completion of the PhD, that partial becomes permanent. Got a point? So this is what the PhD means. Understand these things? Okay. So one thing which came up, that if you want to do PhD, people think that you are very intelligent. So similarly, the question is it necessary to design a controller? Okay? If we understand these things clearly, you will see today's lecture, your understanding about the control engineering will be 70% clear. Let us see. We'll see. Those things are writing, forget that. This analogy which I am giving, suppose you have got a child, teenage child, and he enters into, we said grammar school means higher secondary schools. Class 9, 10, 11, grammar school, okay? Higher secondary school. Now suppose, today, your child enters into a grammar school, higher secondary school. The question is, will you employ a tutor from today? You tell me. Let us answer it. Very carefully. You understand the question first? You have got a son or daughter, and she got or he got admitted into the school. Today, will you employ a tutor to come to your house and teach your child? Certainly not. You are not that fool. Clear? You are not that fool, because once a tutor is coming to your house, you have to pay money. What a point? You are not that fool. Now, see here, consider the example of a student studying in grammar. Grammar school means the higher secondary school. Assume that the student has opted the following courses: physics, chemistry, mathematics, and English. Now, what you will do? You will not employ a tutor. You will wait till the first term examination, school examination is over. Right? First term, school test. After 2 months, there will be a school test. Suppose he has taken these 4 subjects. Now assume that this is the percentage. He has got physics 90%, chemistry 85%, mathematics 95%, English 70%. Will you engage a private tutor? No, because they almost desired performance. Wait till the first test to study the open. Wait till the first class test, that is, study the open loop performance of the system. Study the performance of the system without the controller. That is the open loop performance of the system, right? Student performance without private tutor. You first do it. That is the. Now let us see interesting things are coming up. Now suppose after the first test, this is the performance. See. Open loop performance of the students, suppose the marks of the students got without a tutor. Tutor is the controller, we'll see. After the first test are as follows. Physics 87%, chemistry 78%, mathematics 94%, English 10%. What you will do? There is no other way out. You have to employ a private tutor. Yes or no? You have to employ a tutor. Controller is a must, right? Then again the problem comes. So, I need a tutor. Otherwise, you will not get your dinner at home. Your wife will beat you. What the hell you are doing? Your child is scoring 10% and you are thinking that he will become a Shakespeare. Right? Now 10% in English. Horrible performance. There is no other way out. Then what I should do? I have to employ a private tutor, right? Should I go to the outside this NIT campus and stand on the road and hold my hand? My son has got 10% in English. Will anybody interested to come and teach my son? Should I do that? If I do like this, then many people are driving, they will stop there. Okay, I am unemployed, I will come to your house. Because they will get money. Yes or no? Should I do it? Should I go to the Panjim railway station and ask? So many people are coming out of the train. My son is doing 10% English. Anybody is coming? Should I do that? Should I do it? So I must employ what? An appropriate tutor. Appropriate, not any controller. We'll come to that point. Not any. There are many types of controllers. I have to employ an appropriate tutor. Who is the appropriate tutor here? Either an English graduate, or if I am in academics, I will go to the English department. Okay, Faculty of Humanities. I will talk to the English HOD. I will say that, you see, do you have any PhD students who are interested to teach? So he will say that, okay, I have a couple of PhD students, I will ask them. So you get an appropriate tutor, right? Those people who have got knowledge of what? English, right? That is called the appropriate controller. We'll come to that point shortly. Employ an appropriate tutor. In this case, an English graduate at least, minimum English graduate, right? Now let us see. You studied the open loop performance. You found the open loop performance is significantly below the desired performance. So you have to employ a tutor. You have to employ an appropriate tutor. And you got the appropriate tutor. The tutor is coming to your house. He is teaching to your child. Everything is fine, right? Now the next question is, very interesting question. Second test comes. First test is the performance. By second test, there is a tutor coming to your house, teaching there, right? Suppose we engage an appropriate tutor to teach the student. Are we sure that the performance of the student will improve in the next test? That is the important point. Can you guarantee? Can you guarantee that the performance of the student, your child, will improve? Everything is perfect now. Tutor is perfect. Very nice person. English graduate. Even English gold medalist coming to teach. I will tell you, this is the universal truth. What is the universal truth? There is some universal truth. Universal gate, NAND gate, NOR gate. Correct me, Professor Vida Kumar, I have no knowledge on the electronics now. NAND gate, NOR gate, right? Universal truth. There is another universal truth. All the married people knew it. Two people in the entire cosmos, if there is multiple universe according to string theory, that is truth. Two people in the entire cosmos, they always think that you are not useless, you are bloody useless. Who are they? One is your wife, another is your child. Your wife will say, what you are teaching to the students? They are listening to you. Huh? You cannot explain me how to run this Excel spreadsheet. I am asking you. You cannot put the towel in the proper place. How organized you are. And my son, who is also an engineer, electrician engineer, he said, Baba knows nothing. Yeah. You cannot switch on the television, cannot tune it properly. Yeah. Sometimes when I was teaching him, he said, okay, Baba knows a little bit of mathematics. Otherwise, he knows nothing. Yeah. And he will tell to my PhD students, your luck is very bad. You are doing PhD with my Baba, my dad. My student says, Dr. Swami, son is always son. He will never understand you, right? So they will think. Now, your son does not listen to you. Your son doesn't listen to your wife. How do you guarantee that your child will listen to that tutor? Performance is bad in English. You employed appropriate tutor. But if the child does not listen to the tutor, no matter what he teaches, performance will be bad, yes or no? What is technically it means? The system is uncontrollable. The system is not listening. System is uncontrollable. Then, gone, right? I am coming to this uncontrollable. You see? Suppose the student does not listen over, carry out any advice of the tutor, the system is uncontrollable. Then no matter how good the tutor is, the performance will not improve. Clear? So don't design the controller because you are intelligent. It is not an intellectual gymnastics. There are so many steps. Okay? More complications are coming, just wait. System is uncontrollable. So before employing the private tutor, the controller check whether the student is willing to listen to the tutor. That is, test the controllability property of the system. And if the system is controllable, then employ appropriate tutor. Right? These things has not been mentioned in many of the textbooks. Controllability. What is the meaning of controllability? Let us understand very clearly. I will tell this boy or the gentleman, please bring me a cup of tea, and he obeys my command, then he is controllable. Please do this job, and he does it, he is controllable, right? Take me to Panji to see the sightseeing, he is going with me, he is controllable, right? And if I ask him, please bring me a cup of coffee, suppose he said, am I your servant? Why the hell I should go? Uncontrollable. Yes or no? Then I will say he is uncontrollable, right? That is not the correct thing. That is not correct. So whether he is controllable or he is uncontrollable, controllability is not the intrinsic property of the system itself. Now, I will ask him, please go, let us go to the Goa to see a movie, and he is not obeying with me. He is not obeying my command. Uncontrollable. But his girlfriend is coming and telling, let's go today away to the beach. Oh, let's go. How come it's possible? The same person, when I tell him to go to the beach, he is telling that I will not go. But his girlfriend is telling that let's go. He is going, yes or no? So how can you say he is not controllable? So controllability depends not only on the system, but the person who is telling the input matrix. The system as x dot is equal to x plus bu. A is the system matrix, that is the property of the system. B is the input matrix. Who is telling it? So the controllability, if you see the mathematically, the controllability of the system, I am showing mathematics, then I will B, AB, A square B. You see? These things. You should have full rank. So the B matrix, who is telling? Who is telling? Right? My son, I always say, he will not take some of the dishes my wife makes. But I've got a friend, his wife, she is very strict. He will tell, you have to take these things. There is no other way out. System is uncontrollable at home, controllable there, that place. Got a point? Input matrix, who is telling? Okay? Suppose you don't, if your colleague says something to do, you will not do it. But a director says, you will do it. So controllability is not an intrinsic property of the system itself. It depends on the input matrix. What is the meaning? That means if the system is not controllable, you change the signal which is coming, Change the different places you place the sensors, you get different signals to make the system controllable. Right? So before designing a controller, is it visible? Okay. This is from my book. I have put it here. I'm just doing it line by line. Sorry. Start. Define desired specifications. Study the open loop performance. Open loop performance is equal to desired performance? Yes. Stop. No need for controller. If it is no, perform controllability test. Controllable? Yes. Design appropriate controller. No, make the system controllable by modifying the input matrix and then do it. Right? So these are the steps. Okay? And these things, this procedure has to be followed no matter which type of controller you are designing. Right? But one thing I must tell you, you must be very careful. Controller is an outside element. Understand the analogy? Analogy is not clear. Controller is an outside element. He is coming to your house. He is entering into your house. Remember, state variable, you are entering into the house, not transfer function that you are standing outside the house. Transfer function is the outside external description. State space model is the internal description. Transfer function we will discuss tomorrow while talking about modeling. Because now you know you are entering into the house, you know everything in the house. Right? Now suppose that tutor is a young fellow, I am not telling because this is recorded for the offline. Something happens in the house because you have got other members also. So instead of improving it, it will deteriorate the performance, it will make the system unstable. Got my point? So you must be very careful while employing a controller, right? So, but controllability test is a must. But while doing the controllability test, be careful, it is not a property of the system. If it is not controllable, change the input matrix, right? Design the control. This is the standard thing, testing controllability. System is controllable if it's possible to move the state from any initial state to any final state. So those things are there. I assume that none of you are teaching control course. How many of actually you are not, have you studied control course before? While you are student, right? When you become staff, then you say that the control people are useless people, will not teach or will not write. No, that's understood. There is no need of telling it. Now I'll make very interesting things, I'll make it here. No, not that I'll make interesting things, I'll make those things which may be interesting for you. This is controller. You will get used to it, my handwriting by tomorrow. This is the system. And this is output Y, this is Y reference. Plus, minus. This is the error. And this is the command signal. We said command signal, VUC, going to the system. Understand it very carefully. Okay? These type of control systems are called the output feedback control systems. What are called? Output feedback control systems, because the output is fed back to the input. You compare it, error is there. Then the output of the controller is the command signal, right? If in future you will study control engineering, you ask the students like this. Y reference is equal to Y. This is the error, right? You want this error should be 0, yes or no? Then now the moment the error becomes 0, the error is going to the controller, so the UC becomes 0, then output becomes 0. You got my point? Just think of these things. It is a confusing thing, actually. No book has given this type of concept. Your reference, you understand the question first. You are comparing, you want the error should be 0, and the output should be equal to reference. But the error becomes 0 means the output will be 0. So what is that? I'm just giving that so many words to explain it. Remember here, I'm just giving a diagram here. This is the error, and this is UC. UC is here, you see here. This point, right? One case. Some constant. You see, with the error is 0, the error may be 0, but the command signal is not 0. See here, the one diagram I am showing here. Okay. So that command signal is not 0. Always remember. If the command signal will become 0, then everything will be 0, right? Anyhow, so this is the output feedback control system. Classical control, the control design is essentially output feedback. You take the output feedback, get the error, design the controller, dies. In the state variable model, you are entering into the system and you know each variable of the system, right? So we use all the state variables as the feedback. So this state variable model, so the control signal you see is equal to say minus of some gain k1 into x1 plus k2 into x2 plus k3 into x3. You see like this, state feedback. Okay? If I am teaching control theory, I will tell you one thing. Only one mathematics, one or two mathematics, you can know it. I tell always the students 3-4 mathematical tricks. Okay? The first thing, just to show their interest. This is what I do it in the class. In the first control course. 3 plus 4 is equal to 6. The question is, correct this. Wait, I think not coming. No, it is frozen, I think so. Yeah. 3 plus 4 is equal to 6. Correct it. Can anybody correct it? Tell me. Yeah. Not equal to 6. Okay, one. Anything else? One answer is 3 plus 4 is not equal to 6. That's fine. Okay. Any other answer? 3 plus 3 is equal to 6. That is all correct. Okay. How many answers are there? How many answers? Infinite. Okay, I did not put any restriction, right? I did not put any restriction. If I put a restriction without changing any numbers in the left-hand side of the expression, without changing the mathematical symbol, you correct it, then you will change the 6 to 7. Clear? So if a problem has got 10 number of possible solutions, putting 9 restrictions, 9 constants, we will get a unique solution, right? Theorem says that. That's one thing. Then another important point is, if this point is coming by the other side, I think. X dot, if x dot is equal to ax, then xt is equal to e to the power at into x0. Okay? X dot is equal to ax means xt is equal to e to the power at into x0. What is the time constant of this mode? The time constant, only these things, if the students understand it, time constant is equal to 1 by a. This is e to the power at means time constant is 1 by a. Right? 1 by a, that's the, only this much would have to understand, 1 by a. So if a system has got a pole at minus 10, then xt will be equal to e to the power minus 10t into x0. Okay? What is the time constant? What is the time constant here? Lambda 1? 1 by 10, that is equal to 0.1, right? Now, suppose minus 100, what is xt? E to the power minus 100t. What is the time constant? 0.01, right? There is a term called engineering infinity. What is it called? Engineering infinity. This e to the power minus at, this will go to 0 when time t turns to infinity? Yes or no? What is the meaning of that? Who has seen infinity? Who has seen infinity? Nobody has seen. What is engineering infinity? 5 time constants. By 5 time constants, 5t, that is called infinity. 4 time constant also infinity. By that 5 time constant, the system, second order system, 98% of its final value. So for all practical purposes, 5 time constants is the infinity, right? Now, this is fast or this one is fast? Which one is fast? 100 is fast, right? So if the poles are away from the j omega axis, why I am telling this thing, I will tell you. Poles are away from the j omega axis, the system becomes fast. Closer to the j omega axis, system is slow. Right? Clear? Now, I want, there is a powerful controller. So now we know location of the poles decides whether system will be faster or system will be slower. Suppose this is the j omega axis. If you are closer to this place, your response is slow. If you are away from that, response is faster. Right? The state feedback controller is not output feedback controller. Remember, it's not output feedback. If the system is controllable, it is possible to place the poles anywhere in the S-plane by suitable selection of the gain matrix. You will do it today in a tutorial by giving the MATLAB command, place command. Say, for example, I want you should be very fast. So what I will do? I will ask you to go outside the room and go to the road. Okay, that is far from this place. You will be fast. If I want the system to be slow, then I will tell that you come closer to this place. Right? The j omega axis. If the poles are here, closer to the j omega axis, response becomes slow. Away from the j omega axis, response is faster. So, if the controller can do it, it can place the poles anywhere. Suppose the controller will place anywhere, system becomes faster. Right? All the outputs cannot be states. Yeah, I understand. The X and I, it all depends. Now, his question is valid question. Suppose I have got a third order system and it has got 3 number of outputs. 3 outputs and 3 states. So in that case, state feedback and output feedback are the same. What a point? So usually the state feedback means more number of states. Usually the number of states are more, usually. Otherwise, if the number of outputs are similar to number of states, then state feedback and output feedback are the same. Okay. Or even, no. Even for a fast order system, if that is the output feedback and state feedback, that's the same. No, state can measure that thing will come up, coming to that point. But in general, what I am emphasizing here is, I will tell you interesting things. The theory says if the system is controllable, step number 1, then it is possible to place the eigenvalues anywhere in the state space by state feedback, not by output feedback. Let's assume the output and the number of states are more than the outputs. When this theory came, 1970s, There are some journal papers. What they do, they publish papers and they will say, we are designing state feedback controller, placing the poles anywhere by output feedback. The theory does not support that. They will show the response. People have not understood, this is not the control theorist. It is going to the other journal. What am I? So output feedback, it is not possible. It is happening, that's fine. But output feedback alone cannot do it. State feedback cannot do it. Okay. The only problem is state feedback controller is very powerful controller. Okay. As Professor Amal told, we are coming to that states has to be observed. We will come to that point. The problem is, I gave a very generic statement. If the poles are away from the j omega axis, system is faster. Closer to the j omega axis, system is slower. Right? But what do you want? Where actually you have to place the poles? We don't know it. So that is the difficult part. First difficulty. And second difficulty is, the states are not measurable always. One difficulty, another difficulty is, the states are not measurable always. All the states are not measurable. There are some states may be measurable. I am writing all the states. I am not writing are measurable, I am just may not be measurable. All the states may not be measurable. You cannot measure them. Then what you will do? You are designing a controller, U is equal to, say K1, I am not writing -1, K1 x1, K2 x2 plus K3 x3. Now suppose x1, x2, x3, out of which two states you cannot measure. Then you can do it. What a point? Because after all, you have to measure it, then multiply by certain things, right? So what you will do? If the system is not measurable, the state feedback controller is powerful controller. State feedback controller is no doubt a powerful controller. It can place the eigenvalues anywhere in the state space, right? But it assumes that all the states are measurable. Now, if those states are not measurable, then we have to estimate the states. So, we have to estimate the states by using observer. We have to estimate the states using observer. So in that case, this U will be equal to, see the expressions here, K1 x1 cap plus K2 x2 cap plus K3 x3 cap. Cap means estimated value, because you cannot observe. Huh? Huh? Yeah, if some are measurable, don't estimate it. If some are measurable, suppose x1 is measurable, you estimate those things. That's called the reduced order observer. Okay. So, pole placement controller is a powerful controller. That controller can only be designed if the system is controllable, but it has its own problem. Where to place the poles? First thing. Now, suppose you are an expert and you know where to place the poles, that's fine. But the states must be accessible. If the states are not measurable, you have to estimate it. And who will estimate it? Observer. Observer is a formula, it is an algorithm, it is an equation. It is not a device. Observer is not a device, it is a formula. Okay? Use that particular formula and estimate it and replace it here. Okay? Now, common sense. Suppose the open loop system poles are here. I want to place the pole in the back bench. Case number 1. I want to place the poles outside the building. Where the control effort will be more? Outside. Got a point? So it's very common sense. So again I am modifying the theorem now. If the system is controllable, then it is possible to place the eigenvalues anywhere in the state space by the use of an unconstrained control signal. There is no constraint on the control signal. If there is a constraint on the control signal, that the control output should be this much, then it is not possible, right? Okay. Yes. Constant. Otherwise, how can you place it, right? Now see in this example here, the eigenvalues are placed at minus 1 plus 3j, and you see the control effort is 1. The eigenvalues are placed in minus 5 plus 3j, the control effort is 18. Okay? What a point? Another important thing I will tell you, because in many places throughout the world you will find people are working on power system. We will talk about those things when we will talk about Lyapunov stability later on. See the interesting thing. Some of the statements which I will make here, it may appear controversial, which is not. There is a nonlinear system. You understand this point? There is a nonlinear system. How the power system works, and most of the engineering system work. There is a nonlinear system. We will see all those things in nonlinear analysis. You get the equilibrium point. You get a linear model which is valid if the system is operating within the equilibrium point, in a small region around the equilibrium point. Then you use that model. That model is valid if the system is operating within the small region about the equilibrium point. Use that model to design a controller. Then in the simulation result, you see the journal articles. Simulation result, sudden short circuit in the transmission line. This is the response. I asked in the PhD oral examination of many people in the, what the hell you are doing here? Your model is a linearized model. The basic assumption is it is operating within a very small region around the operating point. You are designing a controller and you are showing the performance of the controller by a sudden short circuit, a large signal disturbance. When the large signal disturbance, the system operating point shifts to any place. So the linear model is no longer valid. The entire mathematics collapses there. Entire theory based on which you are doing the design is collapses. Okay? I always tell to those students, you dump this particular report in the Pacific Ocean. Go. I tell them, you go to Queen State and first dump it. It has no value. Fundamental assumption is around the operating point and the large signal disturbance. How? How is possible? Then they will say there is an argument you see. They will say, no, we put the large signal disturbance. This is our result. You cannot say the result is wrong. You cannot say the result is wrong. That is also true. The question is, what is the answer? Answer is, I am a sober child. I am a sober child. I always obey my parents. I behave perfectly. Whether you are coming to my house, it doesn't matter. You are coming to my house, I am sober. You live in my house, I am also sober. Your presence in the house doesn't matter me. The power system in general is always stable. It behaves nicely. You are designing controller because to get it published in the journal. Power system doesn't require it. It is almost stable. We have got around 12 students PhD, 12, 15 students PhD. one student is working on multi-agent control, power system. MPC-based sliding mode control. I told, what the hell you are doing, man? Deep learning based. One of my PhD students from Indonesia, Gunawan Dewanto. Gunawan is doing on the deep learning based controller. I told Gunawan, one day Gunawan and myself, we laughed. I told Gunawan, you know and I know. This is all nonsense. Because why the hell I require a deep learning network? Deep learning network is required by Professor Veera Kumar working on image processing underwater acoustics. They require deep learning, a convolution neural network to enter to you, right? So you understand what the meaning of deep learning? Deep learning means, suppose he is sitting there, I will look to his face, then I will do some operation, I will see what is in the skin, then I will see what is in the bone, all the nonsense, the deep learning. Go deep. Power system, why I need a deep learning? But we are doing it because to publish a paper. And we are doing it while publishing papers. That is the truth. That's the truth. This is recorded. People should know these things. We are telling this to people, you want to understand, deep learning, a simple PID controller can do the job. What a necessity of using a very complex controller? Huh? Is it necessary the entire power system is completely stable? Power system is completely stable. There is no point. There might be a little bit of stability issue because of the penetration of the renewable energy nowadays. Okay? But why to do that? Deep learning, machine learning, neural network, all these things will also cover. Reinforcement learning. Everybody is doing it. It's necessary. A simple PI controller can do the job. Simple optimal control can do the job. Right? So you are attending this course also. I am telling, MPC when it came up, model predictive control, I tell you, the Manfred Murari who did it in 1990, that is essential for chemical plants, which is slow. I will also teach you one, not tomorrow, day after tomorrow, something self-tuning controller. When it came up, the Carl Ostrom did it in Sweden, then the David Clark. When I was doing PhD, David Clark comes to our university to examine master's thesis. I have seen that guy. And Peter Gothrop, one of his students, he was editor of the journal, International Journal of Control. He comes to the university. Our department is control department. Many people come. Those are the people who have developed these generalized predictive controllers. GPC, you can go to Google, you can search it. Steve asked, hey, David, why are you doing this GPC? Do you think that it is useful? Steve, don't ask those such questions. It certainly came to our mind and we just did it. Right? So, things are different. What you are studying here, machine learning, neural network, which you will do it in this course, that's fine, absolutely fine, no doubt about that. But you must know when a simple PI controller can do the job. Why to do this? Okay, just so anyhow. So any questions until now? State feedback controller can do it anything, anywhere in the state space by constant control signal. If the states are not measurable, then you design an observer. How much time is there? 5-10 minutes or 5 minutes? 5 minutes I will close it. Okay. Oh, no, sorry. Please. Wait. Why is it not coming? Yeah. Major problems of state feedback control design. You should estimate the states. You cannot estimate the states for all type of things. Suppose I will cover everything. I am talking here, I will cover everything. Observer means from the output, you can observe what is the states. I am giving an analogy, things will be clear. You go to the particular person house, okay? Your system is not, you see, you are not allowed to go inside the house, right? Suppose you have got a son, you are looking for a girl for his marriage, right? Then you go and tap the calling bell. The person will come, you ask him. You are not telling your intention. Oh, where are you from? No, I am from this place. What are you doing here? I am doing these things. Is your wife is at home? Yes, yes, he's there. Then she will call his wife. Then some discussion, then you find that the gentleman and his wife, they look handsome and beautiful. Then you came back, then you tell your wife, okay, I will go with the formal proposal. So your wife will ask, did you see the girl? No, I did not see the girl. See the point. I did not see the girl because they did not allow me. But from the look of the father and the mother, I could estimate that the daughter must be beautiful. Observe her. From the output, I can observe what might be the state. You got my point? Estimation. Okay, not measurement. Measurement is different. Estimation, I am estimating. Now, if the system is observable, then you can estimate the step. Now, suppose the father and mother, they came with full cover. They are talking to you, but you cannot see them. Then you cannot estimate. So, to estimate the state, the system must be observable. Right? System must be observable. Estimate the states. Oh, all these mathematics are there. There are different types of controllers. We will see. Many things we can discuss offline, but I will tell you something here before I close it within 5 minutes. The most important controller is called the PID controller. I just tell you a little bit. Proportional controller, derivative controller, integral controller. It works on how much is the error. P controller, how much is error. This controller works how the error is changing. I will give an analogy, then things will be clear. Just a minute. How long the error persists. Are you getting to my handwriting now? After 1 hour? How long the error persists. Now suppose there is your son. Suppose he is in the mathematics out of 90, he is scoring 30. So there is a large gap. Large gap in the error. How much is, so proportional controller will work. You have to change the proportional gain. So instead of 1 hour mathematics, he should study 3 hours, 4 hours, right? How the error is changing. One test, he is scoring 90. Another test, he is changing 10. Another test, he is scoring 80. Another test, he is changing 50. So you see, it is changing. There is no consistency. So they are the, right? Derivative control will take care of. So if the error is changing, it will work. How long the error is persisting? Now, your child performance is bad. Whether it is bad in this, he is an eternal idiot or a temporary idiot. That means from the class 1, he is scoring 5, class 2 also 5, 6, 7. So he has been performance in this, what is that? In mathematics is always less. How long this particular behavior is there in integral controller? Is it recorded now? Okay, you can stop the recording a little bit also, otherwise it doesn't matter. My wife is not going to see. Now see here, I give this example so that you can remember it. Don't take ladies, don't take otherwise. Otherwise, they will say woman influence all these things. No, no, no. The behavior of a wife is just like an integral controller. They will remember everything. 30 years back, what you have done. Integral controller. It depends, integrate everything, you see. Integral from 0 to infinity. You are doing well now. No, no. 20 years back, my brother has come. During that time, you did not take him to the market. He came last year. I gave him so many gifts. No, no. You know, remember that thing? We have gone to that place. You don't remember that. These things you did, integral controller. Integral controller is exactly similar to your wife. He remembers everything and act accordingly. What I point? So proportional controller, derivative controller, and integral controller. Every house has got an integral controller always. Okay? And you will see, although integral controller has got this bad quality, but it is very useful. That is the only controller which can correct you, it can correct the steady state error. Because of the ladies, the house runs smoothly. So integral controller is useless when you are talking in the social sense, but actually it's very useful. Ladies are useful, otherwise the house imbalance will be there. Right? Everything. That is clear? I'll close the lecture now and we'll see. Any questions? Do you understand anything from the control a little bit? Even if you don't understand, you tell that you understood. So that GAN people will know that you have understood it. Because they are watching us in the live streaming. Okay? See you then. And we'll see in the, tutorial a little bit.